We do it one through graphing and second algebraically. And everything ties in. And the more complex your function gets, the more things we add to it. I don't know if you learned that this exponent up here will tell you how many zeros, how many roots you have for your equation. And whether they're real or not real will determine that also. But you can find out how many roots you have. If you subtract one, you can take how many turning points you have. If you subtract one from that, you get your inflection point. We'll be doing all these things through patterns and graphing, and you'll be investigating these things a lot more. I don't know if you remember your difference quotient from last year. A little bit of, you might have hit it a little bit. We look at equations in this, and mostly we're looking for testing for your functions. A little bit of this is a little bit of review of what we've been doing, because I spent a lot of time with domain and range. I think that if you understand the domain and the range, you kind of understand your functions a little bit better. So I hope you have a better understanding of all your domains, the restrictions we have. What are the three restrictions we have for domains? Square root, fractions, and a square root under a fraction, a radical under a fraction. We only have three domain restrictions when it's an x. Okay. We also have, when we take this and we use a y squared instead of an x squared. Okay. So when we take a look at this, you're going to graph these things as well as solve them algebraically. And we spend a lot of time on your transformations. We spend a lot of time with your core graphs. God bless you. Your core graphs were your squaring graphs, your square root graphs, your cubing graphs, and your absolute value graphs. These are your cores. We spend a lot of time with those, and as we change it up a little bit, we talk about the transformations. And we can find those transformations without even graphing them. Basically, your basic function, you all know this. This is your squaring function. This is your quadratic. This is the one we've been doing when we solved your quadratic inequalities. Okay. If this is positive, A is positive, it's going to open up. And some of this we already know. If A is negative, it's going to open down. Your domain, there are no restrictions. You just told me we only have three. There's none of them in there. So your domain is all real numbers. What happens when you plug an x in here, anything that you square, you'll never get a negative out of, right? So your range is limited. Not restricted, but limited. Our range says from 0 to infinity. Whatever x value we put in there, we can never get a negative number out of it. Same thing with your absolute values, unless we do a transformation on it. So those are the things we're going to look at through here. And basically, this is just pulling together your functions a little bit more. We're going to talk about function notation, just to kind of get you guys back on the same page. We're going to test for a function. Whenever you test, you're going to solve it in terms of y, and you're going to make sure that every x has one and only one value of y. And that's your vertical line test as well. So we can do this algebraically, or we can do this with your graphing calculator. Do you guys all have, did anyone in here ask to rent one? I don't think anybody in here did, right? So everybody has a graphing calculator? If you need the form to rent it, come see me at the end of class, because you're really going to need one. Another nice way to get it is go on eBay. I buy my TI-84 silver editions for $40. Look for good bargains, especially like at the end of a college semester, because the kids sell them so quickly. And they'll say, used one semester only, used 2 semesters. I used this for my algebra class and never used it again. And just kind of zoom in and look at the screen. Usually they give you a picture. Just zoom in and make sure your screen is good. Because pretty much the only thing that can really be bad is the screen. Like every once in a while you get a key that sticks, but you know, if they've only used it a short time, they're pretty good. So if you're going to go on in math, it's good to get one and have one. So when you solve these things, you're going to solve in terms of y. Now this guy, you can tell right away. What's this going to be? This equation. Parabola. It's just going to have some transformations here. So we're going to get y by itself. And we're going to divide everything by 2. So, yep, we have this. I'm going to take this out like this. For now. Just put the 1/2 out in front of it. And if you want, you could distribute it either way. It doesn't really matter. Either way. So we know we've got some kind of transformation going on in there. Every x that you put in here is going to give you 1 and only one y value. Am I going to have a domain restriction because I have a fraction? No. Good. Because the variable is not in the denominator. Only when your variable is in the denominator. Make sure those phones are off, guys. This one, here's the problem with this one. So this opens up, so it opens down somewhere. We know we're okay with that. This guy, let's subtract x. We divide by 2. And now what do you have to do? Square root. Then undo your square. And when you square root, you get a plus or a minus this mess. What this tells me is, for every value of x that I plug in here, no matter what I plug in, it's going to come out with a positive and a negative number, right? Because I've got a plus or a minus. So every x is going to be assigned to 2 different y's. So is this a function? No, not a function. Because every x that I put in is going to have a positive and a negative y. So let's say I put in an x of 3. Let's just try it out. Negative 3 plus 7 is what? Positive 4. Positive 4 divided by 2 is 2. So I have, for when x is negative 3, x is positive 3, I have a y of radical 2, and I have a y of negative radical 2. So this x has 2 different y's. This parabola is opening this way, to the left. And we're going to investigate these a lot more when we talk parabolas. So we can see that it does not pass a vertical line test. Every x is assigned to more than one y. Okay? The same thing happens with your absolute value chord graph. Your absolute value says this. For every x that I put in, I will get the positive value back, the same value for y, with a positive. So every x that I put in has one and only one unique y. And do I pass a vertical line test? So this guy's a function. This guy is going to open the opposite way, this way. And does this pass a vertical line test? No. So this guy is not a function. Because what happens here is the exact reverse of this. There's no limitation on my y. My y can go anywhere, but my x can only be positive, right? So I know my x has to exist over here, and I know my y's can be anywhere. So therefore I know where my absolute value graph is going to go. So even if we didn't realize that, we can kind of figure it out the long way. These are things we'll be working more on as we go through this. Function notation, just a little bit of a review of function notation. Because I always find kids have a hard time when they plug in an x value. When you call your function, this is the name of your function. This is function f. And what is this going to give me? 2x plus 4. What's it going to look like when we graph it? A line, right? It's just going to be a line. So function f is going to give me a line. Function g is going to give me what? Parabola. Function h is going to give me what? Parabola. Okay, when we read this, we read the value of your function at x. In other words, the value of your function is always which one, the x or the y? The y. We plug in the x, the independent variable, you, excuse me, you get back the y value. So your x is your independent, your y is your dependent. So whatever x you plug in, your y, your value of your function comes back out. So do I have any limitations on my x? No. So I have all real numbers. And a line, you know a line has all real numbers. Your line is going to look like this, crossing at the 4, somewhere like this. No limitations on your x value, and your range is going to be all real numbers as well. When you do function notation, this is the x right here. So we say the function when x is 3. The function at 3. The 3 goes into this x, not this side. So we say, well, you could write it like this. This is returning your y value. This is the value of your function. You just perform your operation and you get back your y. You end up with an x and a y value because we have a line. So you end up with an x and a y. Okay? Your function, your value of your function is the y that gets returned. Alright, function g. I want to know the value of g at 2. God bless you. This is your x. Once you plug this in here, you don't do anything else with this side. It becomes your y. This is the side you work, the right-hand side. So your y is equal to 4 minus 1, 3. God bless you. So when your x is 2, your y is 3. And your last one, this is your function h. And I want the value of h when x is 4. So because you're just plugging this in, it goes in both places. You've got 2 places for x. Tomorrow we're going to do a difference quotient, and we have to revert back to this. I know this sounds like, oh, this is going to be real easy, but this is just kind of bringing us all to the same page. And you just can put it in your calculator. You can even put this into your y equals. If you're doing a number of these, put those in your y equal, go to your table, pull out your values of y. It's your function that's returned in your y. So 16 plus 8 minus 1, 23. Do you remember your compositions? Remember compositions of functions? Okay, which side did we start at? Where? The right. We start at the right and we move to the left. No matter how many pieces you have, you start at the right and you keep moving to the left. If we have a number in there, we replace the number. If we have an x or nothing at all, we have to find the equation. Remember doing this? Okay. Let me just pull this down a little bit so I have first. So let's put your 2 in here. Which one does it go into first? G. So I'm going to take it into the G. So I'm going to say G of 2, 2x squared minus 1, which we already did, right? And what was that result? 3. What do I do with the 3? Plug it into F. Now I have F of 3. F at 3. And this is giving me 10. So the value of this composition is 10. Now these are not commutative properties. I can't switch this around. If I did G of F of 2, shouldn't come out to be the same. I'm going to do the F first, unless they're inverses, and we'll talk about that in a little bit. I'm going to put this into F first. This is going to give me 4 plus 4, 8. And I'm going to plug this into my G. So 64 minus 1, 63. Do they come out the same? No. They'll only come out the same if they're inverses. If they're not, they'll be different. This is not a commutative property. Let's do this one. Oh, that's what we just did, right? We just saw that that's not commutative. How about this last one? What am I going to start? H. I'm going to plug in the H of 2. When X is 2, what's the value of H? 7. 4 plus 4 is 8 minus 1. What do I do with the 7? Into F. My function of F at 7, when X is 7. If it helps you, put the X above it. So I go to my function F, and I plug in X of 7. 18. What do I do with my 18? Plug it into G. Ah, very good. Thank you. And that's the composition. Start right and go to the left. Now, that's not right?
She only has one F. It's x squared minus 1.
Say this again?
It's only x squared minus 1.
Oh, I took the wrong G. Thank you. Thank you. Was that 323?
Yeah.
What's this one? 323? So you guys were one step ahead of me. Thank you. Sometimes when I talk up here and I'm thinking what to say next, I put the wrong thing up here. Good to catch me. Now, these work great when you have numbers in them. When you have a letter in them, such as this guy, or sometimes they write it just like this, F of G, and nothing's there. That's the same as putting the X here. They want you to create the equation for this composition. They want you to take this equation, same routine, and put it into the left. So the easiest way to start this is to start with your G of X. I find that I put this one first. Let me get the right one this time. And then it's going into my F of X. Wherever this whole entire thing slides into X, wherever it happens to be. If X is in 3 places, it goes into all 3 places. So I plug this in. I take this whole G. I'm putting G into F. I take this whole G and I slide it into this X. And now I just work this through. So 2x squared minus 2 plus 4. This is my equation for F of G at X. Now, if I'm going to do this problem like a number of times, F of G of 2, F of G of 5, F of G of 7, the easiest way to do this is find your equation for F of G, and then take this 2 and plug it into this last one. So if I plug my 2 in here, I'm going to put the X in for 2 now and see if we get the same as we did over here. We made the equation for this now. This one we did using your numbers. So now we're going to plug this in. 2 squared plus 2. So this will give us 4 times 2 is 8, plus 2 is 10. You see how this 10 matches this 10? If we're going to do this a number of times, it's easier just to find the equation for the composition and then plug them all in one at a time into your new composition equation. Sometimes they will ask you to find a composition with a number. Sometimes they will ask you to find the composition with the x, find the equation. You guys try this. Find me the equation for g of s and x. Find me the equation for that. See what you got. So you're going to take, God bless you. You're going to take your f of x, and you're going to roll this into your g of x. Always going to the left, even if it doesn't look so nice. So we're going to take this whole thing and plug this into this x. You're still going to have to square. You're just replacing the x. And Rich just noticed, oh yeah, he's got to FOIL the whole thing out, right? So get rid of some of this mess over here. So let's FOIL this out for x squared plus 8x, 16 minus 1. Okay, there's my equation for g of f at x. Now, let's see if it works. We did this one over here, g of f of 2. So if we plug a 2 in here, would someone be so kind just to throw this in your calculator? Does this come out to 63? Good, right? Paul's going to check on it, right? Paul will check for us. 63? Okay? So, whether you work your compositions with your numbers, or you have to find your equation if you're going to do them more than once, they should all work out. Remember always to start at the right and move to the left. So just a little bit on your function notation. Now tonight, I'm not asking you to do